All right, so the test is 10 questions. It goes through the linear equations, solving them, and doing some graphs, and then a couple of the word problem topics. So let's look at the first one. The first question is looking at determining which one is the solution to the equation. So to do this one, we basically just have to plug the values into the problem. So for the first one, and they're all done the exact same way. So I have 7x plus 4y equals negative 23. So the first one I have 2, 6. So that's my x and that's my y. So I have 7 times 2 plus 4 times 6 equals negative 23. So we're just going to go through and do the calculations out. So I have 14 plus 24 is negative 23. And then I have 38 equals negative 23. So does 38 equal negative 23? Nope. So that would not be correct. And we do the same thing for the other 3 problems. So I'll do one more of these because I'm not exactly sure which one's right. So we're going to do negative 5 and 3. So x and y. Actually, change the color for this one. So I have 7 times negative 5 plus 4 times 3 equals negative 23. So I got negative 35 plus 12 equals negative 23. So I got negative 23 equals negative 23. So that one would be yes. Any questions on this one? How we're doing it?
I think I'm good on this one.
Okay. All right. Moving along. I know a few of the other ones will be a little longer. All right, so domain and range. Remember, this is the one we're looking at, figuring out if the domain, every input has exactly one output. So in the first two where you have the arrows, you're looking for 2 arrows coming out of one number. So in the first one, leaf, rock, door, and sky, they all have one line coming out of them. So it doesn't matter what the range is, it just matters what the domain is. So this one was going to be a function because they all have one line coming out of them. In relationship 2, even though we've got 2 numbers going to this 3 over here, that's fine because the range doesn't matter. All we're looking at is the values over here, and there's one line coming out of each one of them. So that is also a function. Now, if we look at relationship 3, the first one is y, then u, and the second one is then y, then c. So the first value of y repeats, and it goes to 2 different letters. So as soon as we see that, that's not a function. And it's because of those 2 y's right there. And actually, the s's do the same thing. S goes to y and s goes to s. So neither one of those would work. So if we look at that in terms of a mapping, we'd have something like this. We'd have y go to u, y go to c, s go to y, and s go to s. So because that's my domain, and that's my range. So right there, that's why it fails. If we look at relationship 4, 7 goes to r, negative 8 goes to r, negative 8 goes to y. So right there in the middle, we have the negative 8 goes to r, and negative 8 goes to y. So that's also not a function. Okay, even though the other ones are fine, the negative 8 fails it. Any questions with looking at domain and range for the tables or the mapping and the points?
Nope.
I mean, it's a little confusing, but I think it's something you're just gonna have to try and like think about.
Yeah. So the map, which one's the confusing one, the mapping or the points?
Just figuring out whether it's a function or not, like the lettering wise.
Okay, so the first two, look at the arrows.
Yeah.
If one of the letters have more than one arrow coming out of them, it fails it.
Yeah.
Okay, and the ones where they give you the points, if you want to, you can actually draw it like I did there, and actually make it a little bit of a mapping so you can see the arrows going, and then you can just catch it that way. So that's another
Oh.
option for you. Instead of looking at it just as the points, make the mapping like I did.
Oh, okay. Oh, yeah. Oh, I didn't see that on the side.
Yeah, so and that was just relationship 3. So it's like it just works out nice. And if we did relationship 8, I can do that one real quick.
You don't have to, but I get it. If you
It's-
do like the arrows, it's
I don't mind. I have tons of time. So 7 would go to R, 8 would go to R, 8 would go to Y, and 9 would go to S. So see, that one fails it right there. So you can easily just make your arrows and figure it out from that.
okay. I didn't
Okay.
know that you could do that too. Yeah.
Yep.
Thank you.
Not a problem. All right. Moving on. So the next one's looking at domain and range from a graph. This is the one where you have to look at the parentheses and the brackets. So remember, parenthesis is the open dot, and a bracket is the closed dot. So when we're looking at this one, domain is going from left to right. So we're looking at the x's. So my domain is going from -5 to 5. So -5 to 5. At -5, I have a bracket because it's a closed dot. And at 5, I have a parenthesis because it's an open dot. So that's my domain. The range is going up and down. So the lowest point in the graph is there, and the highest point in the graph is there. So we're going from -2 to 4. -2 is at the solid point, so that's a bracket. 4 is at the open point, so it's a parenthesis, and that's my range. So when you're looking at each one of them, you're looking at that bracket and the parenthesis individually, and it changes based on where we have it. Okay. Any questions with that?
Nope.
All right, now let's get into a few graphing problems. So when you're graphing, remember we're looking back at the y = mx + b. So b is my y-intercept. In this case, my b is 2. So I'm going to put a point on the graph at 2. My slope is -3/4. That's my rise, and that's my run. So
you
from
just go
so from here, I'm going to go down 3
and then run 4.
and over 4, and put my point there. And then we draw our line.
Anytime you graph a line, is that always the equation the y = mx + b?
Yeah, as long as you can get into the y = mx + b, it's always going to be done that way. Sometimes it'll be in standard form, and you have to you have to move things around to get it in that. But
Okay.
anytime you have a straight line, it can be put in the slope-intercept form of the equation.
Okay. Thank you.
No problem. All right. Next problem is looking at slope. So remember our slope equation is y2 minus y1 over x2 minus x1. So we have our 2 points. We're going to plug them into my values. So I have 4, 6, and 4, -3. So that's x, y, x, y. That's my first point. and that's my second point. So we're going to plug these in. So I've got -3 minus 6 over 4 minus 4. So I got -9 over 0. If the bottom of the equation is 0, what does that mean for the slope?
Undefined.
It would be undefined because we cannot divide by 0.
You beat me to it.
I am great at beating people to problems.
Yes, Jacob.
I know. I
However,
was excited. I
give
had that answer.
You want to give him a little bit of a chance, Jacob. A little bit of a chance to answer. All right, let's look at the other one. See if you can get the other one. So same thing with the other one. So I'm going to have my points -4, 9, and 5, 9. So x1, y1, x2, y2. So I've got 9 minus 9 over 5 minus a -4. 9 minus 9 is 0. 5, 2 negatives make a positive. So that's over 9. So 0 over 9 equals what?
0 over 9.
Which equals 0.
Here's
So my
0.
slope is 0.
Yeah.
So that slope is 0. Okay. So just always go back to that slope equation for this.
Thank you.
All right. Word problem. We have a couple of these on the test. Oh, this is that really easy word problem that looks complicated. All this word problem is asking you for is the starting value and the slope. So my equation they gave you is y equals 2500 plus 110x. It says, what is the change? The word change means slope. And slope?
So it'll be
Is
anything.
M.
It'll be the mx. Yeah.
Correct. So in this case, my slope is 110. Because that's the M. Then it says, what is her total pay if she doesn't sell any copies? So that would be the starting point. So 0 or no copies. Or no copies is B, which in this case is 2500. So all this question's asking you for is your slope and your y-intercept. Okay, so you don't actually have to do any calculations for it. All right. We're cruising right along. All right. This one, they want you to write the equation of the line given the points on the graph. This is the one where we want to use the slope we want to use the point slope equation for it because we don't have a clear y-intercept. If one of the points was on the y-axis, I would use y equals mx plus b. But since the point is not on the y-axis, I'm going to use the slope-intercept form, which is the y minus y1, m, x minus x1. So we're going to take one of the points on the graph. It doesn't make a difference which one. If I have a choice to choose, I always choose the ones that are the positives. So I have this point right here, which is 3, 5. So that's the point I'm going to choose just because positive numbers make it easier. You don't have to worry about mixing up signs. And then I also need my slope. So I'm going to take my slope from here. So I'm going to start off at the leftmost point. I'm going up there and over. So I went up by 4 and over by 8. So my slope is 4 over 8. And then that would be my x1 and my y1. So now I can just plug into my equation. So y minus 5 equals 4 over 8 x minus 3. And that's my answer. You do not have to go any further than that. You can leave it just like that.
Where can I is there a way to find like a whole bunch of these to do? Because
Yes.
I definitely have struggled with that.
So in Alex, I've got the chapter 2 and 3 test review.
Yeah, I've been doing it. I've done it a couple times.
Right. So on this question, just keep hitting try again. Try another one.
Oh, and they'll just okay.
And they'll give you an infinite number of these questions.
Okay, I didn't know if there was like, a way that I could just do like a whole sheet of them, but that makes sense. Okay.
Yeah, it'll just keep giving you another one of these, another one of these. That's how I have it designed, so that you can do exactly what you want. Just practice the questions that you really need help on.
Okay, thank you.
No problem. All right, 3 to go. Parallel and perpendicular lines. So remember parallel lines? Your slopes are equal. Perpendicular? Slopes are flipped. And signs changed. So in this problem, my original slope is 2. So my parallel slope is also 2, because they're the exact same. Perpendicular. If I flip over 2, what do I get? Not you, Jacob.
You get 1/2.
Very good. So I get 1/2, because remember, any whole number is over 1. So I get 1/2, and I change its sign, so it's negative 1/2. I'm going to do one more of these with a different slope, but so if say my slope was 3/4. Parallel, same thing. This 3/4. Perpendicular. We flip it over, and it's negative 4/3. If the original problem was negative, the perpendicular one would be positive. So it's not always negative; it just switches. So like if that was a negative, my parallel would be negative, and then my perpendicular one would be positive in this case. The perpendicular one's always got to be a different sign than the original problem. Any questions with parallel and perpendicular lines?
Nope.
All right, 2 more. This is the word problem that we have to come up with the actual answer. So this is the one where we find the slope, and then we're going to use the point slope equation to solve and find the actual number. So in this problem, I've got my 2 points. So my first point is 24.5. Oh, actually, sorry. It's 5. I missed 5. 5 and 24.5. And my second point is 17 and 23.3. So I have x1, y1, x2, and y2. So we're going to find my slope. So we plug in my numbers. So remember the same slope equation. So 23.3 minus 24.5 over 17 minus 5. So I've got negative 1.2 over 12, which equals negative 0.1 is my slope. So in this problem, you do want to get your slope as a decimal. It'll come out to be a nice decimal, not one that goes on forever. So like this one comes out to be negative 0.1, which makes sense because the candles, as it's going down, it should be negative. And that's the other thing you want to look for in this problem is if the line's going down, your slope should be negative. If you didn't get a negative slope, you might have mixed up your points when you plugged them into your slope equation. So, and it should be a nice number. So if you flip this one over and you do 12 divided by 1.2, it's going to give you a different type of number. It's not necessarily going to be very nice. So there are a couple little things you can use to make sure that you have the right answer, even without knowing exactly what you're doing. So now we're going to use the one other piece of information I have is they want to know the candle height after 14 hours. So my X value is going to be 14. So now we're going to plug in all this information into the point slope equation. So I have y minus y1 is m, x minus x1. So I have y minus y1 is going to be 24.5 equals negative 0.1 times x, which is 14, minus x1, which is 5. So y minus 24.5 equals negative 0.1 times 9. And then, so that right there ends up equaling negative 0.9. So I'm going to add the 24.5 to both sides. So y equals 23.6 is my answer. And then once you get your answer, look at it. Make sure that it makes sense. So after 17 hours, it was 23.3. So 14 hours is just before that. So 23.6 makes sense. If you screw it up, you're probably going to screw it up bad enough that the answer is not going to make sense. So
How do you know what one's like y1, y2, x1, y1?
it actually does not matter.
Oh, okay.
So if you had switched the 2 points, it wouldn't have made a difference. The actual value would have come out to be the exact same. So the only difference that would have ended up happening is over here, this number would have ended up being positive, and you would have added like 0.3 to the 23.3, which would have still given you the 23.6. So
Okay.
that's the nice thing. As long as you use one of the points in the problem, it'll still work out right.
Okay, thank you.
You're welcome. All right, last one. This is the independent and dependent variables, the ones we talked about last Thursday. So remember, independent variables are your inputs. They're also typically the question that you're asking. Normally, your independent variables are time. Time is typically an independent variable, not always, but a lot of times. Your dependent
Most of the
variables
time.
are your outputs. They are typically the answers. So the things that which you give back after you add the question. And money is normally a dependent variable. So if there's asking for money, that's typically a dependent variable.
You said it was output, money, and the
answer.
question.
No,
the answer to your.
Yeah.
Okay, thank you.
Yeah, dependence, your answers. So the first question was, for each value of the input u, a function corresponds to a value of the output b. It wants the independent variable. So since it wants independent, it wants the input. And this one tells me the input is u. So the one that has that, the input and output, makes it really simple for you to do. The next one, the amount of a certain medicine taken in the morning influences influences the amount of sleep at night. So here's a perfect example where time is not my independent variable. So the question would be, how much medicine did you take? And then the answer would be, how much sleep did you get? So in this case, how much sleep you got is the dependent, because that's the answer to the question after you know how much medicine you took. So amount of sleep would be my dependent variable. Does that make sense? Because the amount of sleep.
Well, I think it's kind of confusing because the way I would think about it would be like, it depends on how much medication I took. You know what I mean? I think that's why it's a little confusing sometimes.
Right. So
it is confusing sometimes.
The statement you just made is exactly right, actually. So but you missed saying the first part of it. The amount of sleep depends on how much medicine you took. So the amount of sleep is what's depending on medicine. So actually, you said it totally right. If you had added that piece in the beginning, you'd have had it.
Yeah.
So, because if you go the other direction, the amount of medication you take does not depend on how much sleep you got.
Oh, okay. Yeah.
Okay. So it's all about how
Yeah,
you.
no, if I think about it that way, you're right. That makes it makes sense.
Yeah. All right, the last one. Gina works in Adventure Fun Park. She notices the daily number of tickets sold at the park varies with the daily high temperature. What is the independent variable in this relationship? So, which one do you think would be the independent variable? Which one's the piece of information she would know, and then she would be able to figure out the other piece?
The temperature?
So, yes.
No,
in
she
this
would
case,
know.
So
She knows the temperature. Okay.
right.
So the amount of
number
tickets sold depends on the temperature.
correct. The number of tickets sold depends on
Okay.
the temperature. So in this case, the independent variable is the daily high temperature because that's what the tickets is depending on. Because they wanted the independent variable in this case.
Yeah. And when I
Okay.
got this question, I definitely thought it was tickets sold.
Yeah, so it's like
gets
it's one of those,
confusing. Yeah.
if you think about, like, she probably would know how many tickets are sold, but if you're thinking about it before the day begins, like if somebody's trying to plan for it, they're going to know the daily high temperatures because we have a general idea of what those are going to be. So depending on how high the temperatures are, they would say, okay, I need extra staff on because we're going to have more tickets sold. The daily high temperature is what dictates or tells you how many tickets you're going to sell.
The numbers. Okay.
Yeah.
Okay.
Can we do one more of those?
Yes. I got to pull it up though.
I still have to answer the rest of the questions on my test in order to do more of those personally.
No, you don't. No, you actually don't.
Oh, because the
So,
ones I got right, it won't let me re-click.
oh, that's weird.
Yeah. So
Oh.
I can't practice.
Yeah, it just moves on. It's when you get it wrong when it
Oh.
allows you to do more.
All right, let me
Yeah.
solve that problem. I fixed that problem.
I know because
Alright.
I wrote one down to do for you to help with.
So here, actually, let me share. I'm going to share this one so you can see. Windows one. All right. So when you go in and do a question, you can jump to any question you want.
Mm-hmm.
And once you do it, so let's actually do this one together. So the weight of a package affects the cost to send that package to the mail. What is the dependent variable? So which one is dependent? Is it the weight of the package or the cost to mail the package? Which one's going to be the thing we'd have to figure out?
The weight.
It depends on the weight.
Right. So the cost depends on the weight. So the cost is what we'd figure out. So we would, based on the weight, that's how the cost depends on that one. Remember what I said, money typically is your dependent variable. Because a lot of times money is one of those things that you typically are going to figure out. So, all right, Mary is a runner. Her time to finish the race varies with the number of training miles she runs before that race, which is the independent variable. So is the independent variable the number of training miles or how fast she finishes the race? So which one's going to happen first? The training miles or
The training?
The training.
Right. The training's going to happen first. That's my independent variable. And this one says a function, the output is C, the input is F. What's the dependent variable? Remember, dependent is output. So that's C. Once you check the question, even if you've already done it, you'll see another button down here. See how it says try again? Try another one? Just click it, and boom, you have another problem.
Good. Because I was trying to re-click the green. Oh, now it's letting me do it. Never mind.
Yeah, I fixed that problem. No problem. So yeah, it'll always allow you to go back and do as many of these as you want.
Okay.
So,
Perfect.
okay. And the other thing is over on the side here, it's got an explanation. So if you click that, it'll give you the full explanation of the problem,
Yeah.
including the answer, and then return. Is up. I want to try another one. Same thing here. It gives you an example that you can work out to look at. So you would ask for number 7. If you go to number 7, you can do the same thing. You get the answer, click check, and then try another one. And it'll just keep giving you questions like this one. Okay.
Perfect.
Yes, do that one.
All right. Give me 1 second. I'm going to do something. I need to do something really quickly. And then I will.
Sorry, but I actually wrote that one down.
Oh no, you're fine. I was recording it because I'm going to post the recording.